This is a professor in the Department of Computer Science and Engineering. I'm going to take the subject wireless ad hoc and sensor network. The topic I'm going to cover is the TCP protocols for wireless networks. So indirect TCP, it resolves the disconnection issues in a mobile internet environment where one of the links in TCP connection is a wireless link. Mobile IP, the mobility is handled at the network layer where packets are tunneled from home agent to the foreign agent. When the TCP mobile host moves with this principle, the tunneling works for the datagram flows. TCP flows will be affected by the mobility since TCP is at the transport layer. The socket contains the source and destination addresses. Socket is an endpoint of communication along with their port numbers. So application uses these sockets to send and receive data. When a TCP connection is established, it remains active until it is disconnected. During the lifetime of a fixed host to mobile host TCP connection, the mobile host could have moved to another location. This breaks the connection and TCP has no way of such a change. The next one is indirect TCP. The I-TCP requires the transfer of connection states from one mobile support router MSR to another. The I-TCP connections to the mobile TCP connection into two segments, namely a regular TCP connection segment between the fixed host and the MSR mobile support router, a dynamic segment between the mobile support router and the mobile host. In indirect TCP, the MSR, the mobile support router, has to perform some transport layer functions. To hand off a mobile TCP connection, I-TCP uses a socket migration technique. So TCP snooping TCP, a link-aware transport protocol for wireless last hops networks. It addresses packet loss issues due to the presence of wireless link. Packet losses causes automatically if you are sending the packet lost in transit causes TCP to back off and timeout, resulting in the poor end-to-end medium communication performance. So you have to if the packet is lost, you have to retransmit again. With the help of the snooping agent present at the radio base station, the snooping agent is present at the radio base station. The lost segments are detected and retransmitted locally. So last hop round trip times are estimated. So the suppression of duplicate acknowledgments corresponding to wireless losses from the TCP sender avoids unnecessary invocation of congestion control procedure by the sender. So for the data flow from the mobile to a fixed host in the backbone wired network, a mechanism known as ELN, explicit loss notification, it allows the decoupling of retransmission from congestion control. So at the base station, the packets were lost in a single transmission are detected with a negative acknowledgement. The packets are not received in amount, sent back to the mobile host. The negative acknowledgement implementation similar to TCP SACK. TCP protocol state machine. So how it works. So when the TCP source enters the SNOOP state, it performs the following. The source stops transmitting all the packets. The source freezes all its timers, the current window size and the values of other state variables such as the retransmission timer value. The source then initiates a root failure timer whose value will depend upon the worst case root repair time. So when the root repairs complete message is received, the data transmission will be resumed and all timers and state variables will be restored. TCP bus. It's one of the most preferred TCP protocols. Its buffering capability and sequence information. It deals with end-to-end connections, whereas it comprises multiple wireless links to provide flow and congestion control at the source, and the destination is not sufficient and not suitable. I-TCP breaks the TCP semantics. The TCP connection is further broken into two segments. So the breaking is necessary since the link between the base station and mobile network is wireless and the special treatment is needed. If this segment model is further extended to ad hoc wireless connection, then the flow and congestion control can be performed in the same way but in a distributed fashion. Split-TCP provides a unique solution to the channel fairness problem, splitting the transport layer objective into congestion control and the end-to-end reliability. Splitting a long transport connection into a short concatenated TCP connection with a number of selected intermediate nodes as terminating points of these short connections. Advantages: improved throughput fairness, reduced impact of mobility. So it implements reliable transmission of control messages through two possible approaches. It will periodically send the probe message to check whether the pivoting element has acquired a partial path to the destination. Each intermediate node is responsible for sending an ERSN message reliably to its upstream node until it receives data packets. The possible questions are: list out various transport protocols for ad hoc networks. Explain detail any two transport layer protocols. Thanks for listening. Thank you.